recording. To multiply two fractions, let's look at example 32 here. I'm going to use two different methods. Some of you might have very good foundation about fractions, but my experience tell me majority of students, they don't remember how to process fractions. So I think it's necessary to go over the methods again. Yeah, I'm going to use two different methods to multiply the two fractions. The first method, I'm going to multiply across the two fractions and then simplify. Multiply cross and then simplify. So we have negative 30 over 100 multiplied by, the multiplication symbol can be written as a dot, right? Dot is also means a multiplication symbol. Multiplied by 5 over 6. So when I multiply two numbers with the signs, the first thing I do is to determine the sign. We all know when two numbers have the same sign, their product is positive. If both of the two numbers are positive or both of them are negative, then they multiply to a positive number. If the two numbers we are going to multiply together have opposite sign, then the product must have negative sign. In this case, the first fraction is negative, the second fraction is positive, so the product should be negative. So I always determine the sign first, and then I process the absolute value part, 30 over 100 times 5 over 6. Formula for multiplying two fractions is a over b times c over d equals ac over bd. Here b is non-zero, d is non-zero. Yeah, we all know denominators of fractions cannot be zero, have to be non-zero. So fraction a over b times fraction c over d equals ac over bd. So simply multiply cross. Numerator times numerator is the numerator. Denominator times denominator is the denominator. You see that? So we are going to use the formula to multiply cross to get a result, the product. Numerator times numerator. So basically we have a rule here. When it comes to the multiplication of fractions, the numerator of a product is the product of numerators. The denominator of a product is the product of the denominators. So basically means top times top is the new top, the top of the result. 30 times 5, we have 150. And the bottom times bottom will give us the bottom of the product. 100 times 6 gives us 600. All the problems, if the result is a fraction, yeah, we need to simplify the fraction, write the fraction in the lowest term. So the following a few ways to describe simplifying a fraction. When you see the problem requires you to simplify a fraction or reduce the result, if the result is a fraction, or write the result in the lowest term or lowest form, they all mean the same thing, means to simplify the fraction. Remember how do we simplify a fraction? We want to find the common factors, right, of the numerator denominators, and then divide the top and the bottom by the same common factor. How do we know if the result is simplified? If the result whose numerator and denominator are co-prime. Co-prime is a concept we learned on Monday. Then the result is simplified. Yeah, here, numerator, the last digit is 0. Denominator, the last digit is 0. Remember, I give you a few tips, right? Yeah, how do we know if a number divisible by 2? How do we know if a number divisible by 3, by 9, by 5, by 10, right? Yeah, the last one says if the last digit of a number is 0, then the number is divisible by 10. Okay, that means both numerator and the denominator of this fraction is divisible by 10. 10 is a common factor of the top and the bottom, so we can divide both top and the bottom by 10. And this gives us, don't forget the negative sign, numerator 150 divided by 10, 15. Simply just remove the 0, right? 600 divided by 10, 60. And 15 and 60, they are still not co-prime yet. Obviously, 15, 60. Yeah, what's the GCF, guys? 15, 60. Are you able to tell the GCF? Well, you can continue to divide by 10. Yeah, 15, exactly. Yeah, I hope you still remember the first special case when finding GCF. If we have two numbers, let's say 15 and 60, and the smaller number happens to be a factor of the bigger number, the bigger number is a multiple of the smaller number, then the GCF is the smaller number. I'm so sorry. So 15, right? Yeah. So 15 and 60, the GCF is 15. So we are able to divide both numerator and the denominator by 15. 15 divided by 15 is 1. 60 divided by 15 is 4. So the result is a negative 1/4. All right, so this is the first method. We use the formula of multiplying two fractions and then reduce the result. In some cases, this method is pretty convenient. In this problem, using this method, not too much trouble, right? Especially if from the very beginning you can tell 150 actually goes into 600 4 times. Then you know the numerator and the denominator, GCF is 150. Then you can just reduce the result in one step. Divide both top and the bottom by 150. You have 1/4. Remember, don't forget the negative sign in front of it. Okay. Next method I want to talk about is called the butterfly method. I sometimes call that bow tie method, simply because of the shape of the expression. So we have a negative 30 over 100 multiplied by 5 over 6. Yeah, let's see, how do we use the butterfly method or bow tie method to find the product of the two fractions. Yeah, the sign is still negative, the result is still negative. And then regarding the two fractions, 30 over 100 and 5 over 6, we are going to do this. We are going to draw a bow tie or butterfly shape. Yeah, we're going to do vertical, vertical, diagonal, diagonal. So it's a butterfly or bow tie shape, right? Yeah. So let me explain what does that mean. We do one step at a time. The first step is vertical. Vertical means I'm going to look at the first fraction I have and then to see if I can reduce it. if I can simplify it. 30 over 100. Do you think we can simplify it? 30 over 100. How do we simplify it? Do 30 and 100 have any common factor? Yes, 10. Very good. So we can simplify 30 over 100 to 3 over 10, right? And 3 over 10 is reduced because 3 and 10 are co-prime. 10 is not divisible by 3. So they do not have any common factor except 1. So that's the first step. Second step is to simplify the second fraction. So second fraction, the vertical, right? Yeah. Vertical, and this is vertical. And 5 over 6 is already simplified. So we just copy it. Sometimes we can, if it's already simplified, we can skip that step. And third step is we look for common factor on this diagonal. In this diagonal, we have two numbers, 5 and 10. 5 and 10. Do 5 and 10 have any common factor? Any factors in common? Special case number 1 again, right? You should see that over and over again, that special case number 1, finding GCF and LCF, so useful. Yes, 5 and 10, the two numbers on this diagonal direction, we have GCF 5. Then what we can do is we are going to cancel 5. We are going to divide 5 by 5 here, divide this 10 by 5. And then this expression will become negative 3 over, 3, the upper left and the bottom right remain the same, right? Upper left is 3, we didn't change that. Bottom right is 6, we did not change that. The two numbers we are going to change are the two numbers on this diagonal. So 5 become 1, 10 become 2, right? And now we're gonna deal with the other diagonal. Yeah, my question is, do you see what happened on this diagonal? Yeah, you can mute yourself once you answer your questions, or check your setting of the microphone. Yeah, I want to know if it's clear that we are able to cancel common factor on this diagonal direction. The reason we can do so is because this factor is on the top, this factor is on the bottom. When the numerator and the denominator have common factors, we can always cancel the common factor. All right, so let's check the other diagonal. The other diagonal, 3 and 6, right? Do they have any common factor? 3 and 6. First special case again, right? 3 and 6. Yeah, exactly. Thank you. So we are going to divide 3 by 3, 6 by 3. So we have a negative sign here. Yeah, let me erase that sign. And the top left, 3 divided by 3, we have 1. And copy the 2 on the bottom, multiplied by, on the upper right, we have 1, copy it. On the bottom right, 6 divided by 3 is 2. And then we multiply across. So the steps are vertical, vertical, diagonal, diagonal, and then multiply across. We have negative 1/2 times 1/2, 1/4 again. You know, the benefit of this, or advantage of this method is you simplify those factors, cancel those common factors from the 4 directions, and then you do multiply across. When you do multiply across after simplify, the numbers are quite small. It's more convenient. This method is sometimes not very convenient. Sometimes you have to make the numerator and denominator very large and then simplify. Cannot take the detour. So it really depends on the problem. Sometimes this method works very well. Some other times the bow tie method works more works better. It depends on your preference. Okay. Any questions? I recorded the lesson, so if you want to watch it again, this part, you can always go to the Blackboard and find the video. So that's the multiplication of two fractions. Questions? 3. What is 3? Kellen? What does 3 mean? Oh, yeah. Sure. Okay, got you. And last question is about the division of two fractions. Okay. Let's do the division since I'm already talking about that. 4/5 divided by 2. 4/5 divided by 2. Yeah, earlier the example is about multiplying fractions. Here we have dividing fractions. Dividing fractions is pretty straightforward. One rule only. Keep, change, flip. Okay? Yeah. So that's the rule we need to apply when we divide two fractions. Keep what? Change what? Flip what? And that's the question, right? Keep, because they are verbs. And you have to figure out what do we apply those verbs on, right? When we read a book, think about when we read a book, we read an article on the cell phone, we always go from the left to the right, right? Go from the left to the right. Same with algebra. When we read an expression or when we understand a graph, we go from the left to the right as well. So here the expression what we have, that we have is 4/5 divided by 2. So we're going to go from the left to the right. From the left to the right, we see 4/5 first, right? Yeah, that's the number we need to keep. And then we see the division symbol, and that's the symbol we need to change. And then we see the number 2 behind the division symbol, and that's the number we need to flip. Okay? Yes. Keep the order from the left to the right. What are we going to keep is the first fraction, not the last one, not the second fraction. The first fraction, we'll keep it. And then we change the division symbol to the multiplication symbol. And then we are going to flip the second fraction. The second fraction is 2. We can write 2 as 2/1, right? As a fraction. Yeah, 2/1. And flip here means taking the reciprocal. Taking the reciprocal. What is a reciprocal? Reciprocal is different from opposite. All right? Yeah. To find the reciprocal of a fraction, we simply interchange the numerator and the denominator. Flip the top and the bottom. So we have a 1/2. Okay, that is a reciprocal. It's different from opposite. Number 2, the opposite of number 2 is -2. The reciprocal of number 2 is 1/2. So it's very different. The reciprocal and the original number have the same sign. Opposite have the opposite sign. Okay, opposite means the sign is opposite. Okay, so now we have 4/5 times 1/2. Yeah, we have a 4/5 times 1/2. And the division of two fractions become multiplication of two fractions. And we already went over the methods to multiply two fractions. And look at this diagonal, butterfly method or bow tie method. On that diagonal, 4 and 2 have common factor 2, right? So we can cancel a common factor 2, the common factor 2. Then 4 become 2, 2 become 1, right? Yeah, 4/2 is 2/1. And then we copy upper right, the 1 there, and bottom left, 5 here, and then we multiply across. 2 times 1 is 2, 5 times 1 is 5, so 2/5. Yeah, if you know how to multiply two fractions, then division of two fractions will not be a problem. Yeah, if you know keep change flip. Yeah, apply keep change flip. Convert the division problem to a multiplication problem. Yeah, let's practice. 33. Yeah, am I clear about keep changing flip? Because I did have student before that. They keep the 2 and then flip the 4/5. Yeah, don't do the opposite direction. We keep it from the left to the right direction, all right? Let me copy paste this one. Copy paste. I don't. Number 33. The two factors in the product are fractions, but they are given in a mixed number format. Oh, it doesn't let me to copy. Sorry about that. I need to remember this. 3/5, 1 1/4. 3/5. Three two fifths. Yeah, this means the multiplication of two mixed numbers. Mixed numbers. When we multiply or divide mixed numbers, we better convert the mixed numbers to their equivalent improper fractions first. All right? Yeah. So here, what I would do is determine the sign first. Knowing this is not subtract. Yeah, we mentioned this before. This is a multiply. Multiply this mixed number with this mixed number. The first mixed number is positive. The second mixed number is negative. So the result is negative. If your result end up with a positive number, you definitely got it wrong. So you have to be careful with the sign. And then I'm going to convert 3/5 to the equivalent improper fraction. Anybody would like to help me to convert this mixed number to improper?
Would it be 18/5?
Yeah, exactly. Yeah, let me see, Joe. This is only for division, the keep changing flip. Is that a question, Joe? Yes, that's only for division. Keep changing flip is only for dividing two fractions. When do we use the rule? When we need to divide a fraction by another fraction. Yeah. Or when we need to divide the numbers involving fractions. Yeah. Does it say 17/5? Let's see. Exactly. Yeah, we use the whole number part to multiply the denominator. We have 15, and add the product of 15 on top of the numerator. We have 17. So the first fraction is 17/5. What about the second fraction, the mixed number, 1 1/4? How do we convert that mixed number to its equivalent improper?
Be 5/4.
Awesome, exactly. 1 times 4, 4 plus 1, 5/4. 5/4. Knowing those content belong to foundation 1, we go over this because we're gonna have to deal with fractions in this course, but we cannot cover this section, like this topic, as detailed as we do in foundation 1. So we can just practice a couple questions that bring back your memory, Okay, so now let's multiply the two fractions. Yeah, look at it here. Sometimes the butterfly method is very convenient. What happened is in this diagonal direction, 5 and 5 cancel each other, right? They're gonna both become 1. They're gonna both become 1 because they are the same, right? Yeah, 5 over 5 is 1. So we have negative 17 over 1 times 1 over 4. And then we multiply across. The product is a negative. 17 times 1, 1 times 4 is a negative 17 over 4. 17 is a prime. 4 is 2 times 2. So 17 over 4 is already reduced, is simplified. But if the question requires us to write the result in the mixed number, in the format of a mixed number, we would have to do so. So when you work on your homework, your MyLab Math assignments, make sure you read all the information, especially the requirement. How do you answer the how do you enter the answer in the cell? So we are going to convert this improper fraction back to the mixed number format. Improper fraction refers to fractions whose numerator is bigger than or equal to the denominator. Okay, let's see. Negative 17 over 4, negative 4 and a quarter. Exactly, awesome. That's correct. Yeah. So what happened is we let 4 goes into 17. 4 is able to go into 17 4 times, right? Because 4 times 4 is 16. But not completely. We would have a remainder 1. So the result is a negative 4. The remainder 1 stay on the top over 4. So negative 4 and a quarter. Oh, thank you, Kaden. Really appreciate your positive feedback. Yeah, I wish we had more time to do detail. If this is the foundation 1, I normally win more details, but this is foundation 2, so we only have a little bit time to cover those things. Okay, so that's the unit 1. Okay, unit 1. I hope you have started your homework though. Actually, by the end of this weekend, you should get chapter 1 homework done. Yeah, let's look at the Pearson together. Sunday night, we have a Sunday night. Actually, I did not do this one. Yeah, we have is some other classes. Oops, continue. And another thing I want to explain for the intro assignment that you might see Professor Tracy Jackson's information there. It is because I copy her course shell this semester. The first time I copy her shell, because last semester I used a different shell and too many assignments and 6 exams, too much. So this semester, and especially this is 12-week class, I think Professor Jackson's Pearson design is better. So I asked to copy her course, and I did not get a chance to look at the intro assignment detail. And there are a few questions is only about her classes, and I couldn't change it because you already started the homework. So just to clarify, I'm not Tracy Jackson. I'm Betty Guo, and I apologize for the inconvenience and the confusion. If you need me to override that section, just let me know, okay? I got the answer wrong. Yes. Yeah, just email me, shoot me an email. I can go to your gradebook book and override those questions. I was going to delete them, but the setting of Pearson is once one student attempted the homework, you cannot edit it. You cannot edit the questions. You cannot delete the questions. So I'm explaining what's going on here. I apologize for the inconvenience. Just email me and I will overwrite the question you got wrong for those like those a few questions about Professor Jackson. All right. So in Pearson, so we finished chapter 1 now. This is then you should have chapter 1 assignments done, right? Our assignments, intro, chapter 1 video lessons, chapter 1 homework, and quiz 1. You should have those done, right? I think I did change it. No, I'm sorry, I apologize. So yeah, they are going to due next week. So you should start to work on them and get it ready for chapter 2. All right. So if you have any question, by the way, just ask me. So now let's start chapter 2. What do we do in chapter 2? We do 2 things mainly. We solve linear equation in one variable. And then we also solve linear inequalities in one variable. We also have to deal with the application of linear equations in one variable and the application of linear inequalities in one variable. So mainly 2 things. The first thing, linear equations in one variable. Second thing, linear inequalities in variable. Okay, let's jump into the first concept. In this chapter, we deal with linear equations in one variable. It is an equation, so you would see the equal sign in it for sure. If you do not see an equal sign, then that's not an equation. That's going to be an expression. Equation must have equal sign in the middle. And whatever on the left side, to the left of the equal sign, that's the left side of the equation. And whatever to the right of the equal sign, that's the right side of the equation. All right? And the linear here means when we have the variable appears, the exponent on the shoulder of the variable is 1. It's one-dimensional thing. Yeah. One variable, of course, means in the equation we only have one variable. Yeah, only have one unknown. Anything else appear in the equation. They are known. They are constants, yeah, or symbols. And in the variable always have exponent 1. You will not see x squared or x cubed or x to the power of -1. You will not see those. If x appears, if the variable appears, the exponent on the shoulder of the variable has to be 1. And you will not see the 1 because we don't really write x to the power of first power. Yeah. The variable could also be y or t or any other letters. Most of the time, I use x. Our focus today is to solve a linear equation in one variable. Okay, let's get it started. Let me pick a question here. Okay, I'm gonna do number 9. I have 1 minus 4x equals -8x plus 5. When I need to solve a linear equation in one variable, what I would do first is I would draw a imaginary line here. Yeah, I use a very bright red color line to show you. Yeah, but you can just use a other color. So I make it very clear. I draw a line on the cross the equal sign, and whatever on the left, that's the left side, and whatever on the right, that's the right side. Okay. Yeah, I would analyze the structure of the equation first. Do you guys remember the first class when we met? The very first concept we went over is term. Do you remember that? And I said we don't really have to worry about very complicated terms. All we need to know for the first 3 chapters are the 2 basic types of terms. The first type, a number times a variable. A number times a variable. Okay? And the second type is a constant. Constant. A single constant is a constant term. And a times x is a variable term because it has a variable in it, right? Yeah. Compare with the constant term. A times x. A is the coefficient, is a number. X is the variable. A times x is a variable term with coefficient a. Variable is x. Yeah, so variable term and a constant term. So remember that. The first 3 chapters, we only need to deal with these 2 types of terms. Okay, now, if you remember that, answer me this question. In this equation, how many terms on the left side of the equation? How many terms on the left side of the equation? Yeah, 2. 2, right? Exactly. The first term is 1, constant term, positive. Second term is negative 4x, right? This is a constant term. This is a variable term. The variable term has coefficient negative 4. Okay, I want you to really see it, okay? On the left side, we have 2 terms. And the 2 terms is adding together. By the way, it's always adding. Don't see that as minus. It is actually term 1 plus term negative 4x. Is the addition of 2 terms. Okay, that's the left-hand side. And on the right-hand side, how many terms do we have? Yeah, it's also 2 terms, right? Yeah, the first term is a negative 8x. Negative 8x. Coefficient is negative 8. Variable part is x. So this term is a variable term. And the second term is a constant term. And those 2 terms also added together. So in total, now we can see the structure of the equation very clearly. We have 4 terms in total. We have 4 terms in total. Okay, very good. So when we, do anything, before we start doing the thing, we have a purpose, right? We should be able to visualize what's the result we're expecting. And same with solving an equation. Yeah, here I'm going to write a goal. Goal. Yeah. Here, when we solve an equation, we need to be clear. Yeah, what's the goal of solving an equation? The goal here is isolate x on the left side, on the left. Isolate x. X here is the variable. This is a linear equation in 1 variable, right? Yeah, I use x. Sometimes if it's y, then you isolate the y on the left side. If it's t, then you isolate the t on the left side. Just isolate the variable on the left side. So that is going to be our goal. Okay? Yeah, you need to remember that. Yeah, I hope you remember that. Because I'm going to write this every single time, then you should be very impressed by that. I mean, try to make it impressive to you. Yeah, the goal here whenever we solve a linear equation in one variable is to isolate the variable on the left side. You know, sometimes it's more convenient to isolate the variable on the right side. Depends, but most of the time, it's more convenient to isolate the variable on the left side. So this question, I'm going to isolate the variable on the left side, okay? Isolate the variable on the left side. All right, how do we do that? How do we do that? I'm going to introduce a technique. This technique you don't see on the book. This technique you don't see on the book. And the technique is called transposition of terms. I'm going to explain when do we use this technique and how do we use this technique. Excuse me. We use this technique to collect like terms. Okay, very, very important. Do you guys still remember like terms? Yeah, among the four terms, the four terms are 1, negative 4x, negative 8x, and 5. Those are four terms. Which of them are like terms? I colored them differently, okay? Pink, yellow, blue, and green. Yeah. I think the yellow and the blue are like terms. And the pink and the green are like terms. Do you agree, guys? Yeah. 4x, 4x and ax. Exactly. Yeah, very good. Okay, so collect the like terms. So yellow and blue, they are variable terms. They are like terms. They are both variable terms. And the pink and the green, they are constant terms. Yeah, by the way, this is my teaching style. The very first question of a topic, I spend sufficient time to go very, very slow. So don't get lost, okay? If you get lost, just let me know. So here, our purpose is using the transposition of terms is to collect the like terms. I'm going to keep the yellow and the blue on the left side, and the pink and the green on the right side. That's what I'm going to do. I can do that by applying the transposition of terms. And this technique is very flexible and very convenient. So the yellow term is a negative 4x. It's already on the left side. So I'm going to keep it on the left side. Negative 4x is still negative 4x. And the blue term is a negative 8x on the right side. But I want the blue term on the left-hand side, right? On the left side. Yeah, what I can do is I'm going to move the blue term from the right side to the left side and then flip the sign in front of it. This is a multitask, but if you can drive a car, you can do this. This is only two things in one. When you drive a car, it's more than two things in one, right? Yeah, I believe you can do that. So how do we apply the transposition of terms? We are able to move those terms around from one side to the other side, from left side to the right side, or from the right side to the left side. But what we need to remember is when we move a term from one side to the other side, we need to change its sign. Okay, here, two words. When we switch the side of the term, we need to change the sign of the term as well. So the blue term is negative on the right side, and we move it over, it becomes positive. And the green term is already on the right side, right? Yeah, we want to yellow, the two variable terms on the left-hand side. We want the two constant on the right side. So the green term is already on the right side. do not change the sign, okay? Just simply bring it down. And then the pink term, I want it on the right side. It's so easy, just move it over. Move it over, but remember to change the sign in front of it. The pink term, 1, the constant 1, is a positive on the left side. Then it is supposed to be negative on the right side. Okay? And let me know if you see what I'm talking about here. Every semester I try to teach my method, but students, I don't know how many of them actually, they normally would always go with the method they learn the very first time in the school, right? Like in the middle school, you probably learn this already, and your teacher teach a different method, and you just go with that method. What I want to say is be open-minded. Try this method out. It's very flexible, and it's very useful, very convenient. Let me see if you see what happened here. Okay, yeah, let me explain one more time, and I continue, all right? Yeah, I'm very slow the very first time explaining a process. So this equation has 4 terms, 2 terms on the left, 2 terms on the right. I colored the 4 terms differently: pink, yellow, blue, green. And the yellow and the blue are like terms. Both of them are variable terms. Pink and green are like terms. They are both constant terms. So we want to collect like terms. We want the two variable terms on the left side and the 2 constant terms on the right side. So the yellow is already on the left, so we keep the yellow on the left. And we can move the blue over, and we move the blue over, we change the sign from negative to positive. And then we keep the green term, and we want to move the pink to the right, and we move the pink over, positive become negative, right? Yeah, so what happened is yellow stayed the same. Yellow stayed the same side. Green stayed the same side. Blue is moved from right to the left, so the sign is flipped from negative to positive. Pink go from left to the right, and pink go from positive to negative. Yeah, I like this method a lot. Oh, you already got an answer? Okay. Yeah, let me hurry up. So what do we do? Why do we do this? Because once we have the like terms collected on the same side of the equation, we are able to combine them. Okay, help me to combine the yellow and the blue. Negative 4x plus 8x. Negative 4x plus 8x. Okay, you go to casino, you lost the 4 games, and you lost the 4 x's, whatever the axis is, right? You lost the 4 chips, and then you gain 8 chips, then how many chips do you have? Yeah, the casino method always works wonder. Positive or negative? Positive, right? Yeah, positive. You lost the 4, and then you won 8. You end up with winning. Yeah, win 4x. And that's the left side. Right side, -1 plus 5. You lost the $1, and then you gain $5, and you end up with $4, right? Yeah. And then we are very close to the goal. The goal is to isolate the x on the left side. What do we have right now is 4x. So the last step is we are going to get rid of the 4. I have a question. Yeah, what's the relationship between the 4 and x? 4x same with 4 plus x? And what's the operation between 4 and x here?
Multiply.
Multiply. Yeah, it's not addition, by the way. Okay, it's not addition. You cannot move the 4 over. You can't move the 4 over like what we did earlier. This is one term only. 4x is one term. So at this point, in order to get rid of the 4 in front of x, we are going to divide each side of the equation by 4. Divide each side of the equation by 4. Let me change a different color. Okay, yeah, we divide each side of the equation by 4. And 4 over 4 cancel. We have x isolated on the left side. On the right side, 4 over 4 is 1. And we are done. But if you have extra time, I recommend you always double check. Even logically, checking step is not necessary, but it could help you to make sure your answer is correct. Yeah, we are solving the equation. Solving an equation is a process of finding the solution of the equation. Yeah, what is a solution? What is a solution of the equation? Is a number that satisfies the equation. When you plugging in and the number satisfy the equation, could make the left hand side equals the right hand side. Okay, so let me check for you. Okay, very quick. So the equation is 1 minus 4x equals negative 8x plus 5. Yeah, I'm going to plugging in x equals 1. Yeah, we got a solution x equals 1. We want to know if it's correct. Plug x equals 1 into the equation above. So this is what I do, okay? Yeah, 1 minus 4x equals negative 8x plus 5. Frame x and put 1 into it, and then evaluate. The left side, 1 minus 4 times 1. 4 times 1 is the 4. 1 minus 4 is negative 3. On the right side, negative 8 times 1 is negative 8. Negative 8 plus 5 is negative 3. That is a true statement. Since number 1 satisfies the equation, when we plug in the left side equals the right side, we got a true statement. That means 1 is the solution of the equation. So we got it right. Yeah, it's a very long process. I mean, it's not very long. I mean, I spend a lot of time on it. Yeah, let's summarize. How do we solve a linear equation in one variable? How do we solve a linear equation in one variable? One method is to apply the transposition of terms. Yeah, we could apply the transposition of terms to collect like terms. Firstly, I would draw a line to separate the left side and the right side, and then observe the structure of the equation. Yeah, how many terms over there? Yeah, which terms are which of them are like terms? You know, which of them are variable terms? Which of them are constant terms? Then I use the transposition of terms technique to collect variable terms on the left side and collect constant terms on the right side, and then combine like terms, and then divide each side by the coefficient of the variable, and then we got the result. And let me know, am I clear about that? I believe when you work on this problem, you get it done very fast, maybe even not even being mindful. Not sure it's good or bad. Maybe you're just very good at solving the equation. Since our college college has like a variety, very diverse student group. So when I explain a new question, I go very slow. Question? Am I clear enough? How do we do this problem? I need a practice. Yeah, Jamie. Okay, how about Jamie? Let's try a different method. Yeah, let's try a different method. This method would be the same method that you would see in a book. 1 minus 4x equals negative 8x plus 5. is actually the same in essence. Yeah, but you just do not use the transposition of terms. You use the properties of equalities. Yeah, we have 4 properties of equalities. The 4 properties are addition property, subtraction property, multiplication property, and division property. Earlier, we actually applied the division property. Division property of equality allows us to divide each side of the equation by the same non-zero number. You know, you can treat the equation as a scale. You know the scale, like a weighting things. If you go to the orientation pharmacy, they always have this left side, right side, right? Yeah, if you want to keep the scale in balance, you have to treat both sides the same way. If you add 5 pounds on the left side, you have to add 5 pounds on the right side. If you take away 1 pound from the left side, you have to do the same thing on the right side. If you double the weight on the left side, you have to double the weight on the right side in order to keep the scale in balance, right? Or you can see the scale, see the equation as a seesaw, right? Yeah. How do you play? You cannot. You wanna treat the each side the same thing. I don't know if you can play if this person a lot of. I don't like the seesaw analogy. I would use the scale. Yeah, the scale is a very closely describe what's going on with an equation and solving an equation. So here we are going to apply the formula, the properties. Okay, yeah, addition property means we are able to add the same number to both sides of the equation, and we are also allowed to subtract the same number from both sides of the equation, where we can multiply the same number to both sides of the equation, or divide each side by the same number. So either way, you know, you have to be clear. Your goal is to isolate the variable on the left side. Okay, your goal is to do that. That's the reason. If you want to isolate the x on the left side, you want to make negative ax disappear from the right, right? In order to make the negative 8x disappear from the right, what you can do is to add its opposite. Okay, yeah, because we want the x isolated on the left side, so we want the negative 8x disappear from the right. How do we make it disappear? We use the addition property. Add 8x to negative ax, then it will be disappeared. But we cannot only do this on the right side, we have to do this on the left side as well, right? Okay, after this, you can see they cancel, right? They canceled. Then on the right, in the middle, we have the equal sign. So on the right side, we only have 5. On the left side, we have 1 plus 4x. 1 plus 4x. Yeah, negative 4x plus ax. Yeah, you lose $4 and you win $8. Yeah, vertically, as you can see, is aligned. Negative 4x plus ax give you 4x. And then very close to isolate the x on the left side, since 1 is a constant term, we want 1 disappear from the left side. So in order to make a 1 disappear, we are going to subtract 1. This is the subtraction property of equality. So we minus 1 from each side. Positive 1 minus 1, they cancel. They cancel, right? They disappear. And we only now have 4x on the left side. And 5 minus 1, yeah, they are aligned. 5 minus 1 is 4. And then we apply the division property. Divide each side by 4. Yeah, that's the same with earlier. And we end up with x equals 1 as well. Yeah, you might like this method. I don't like this method because it's too slow. And you always have to draw a line. And what if your equation has a lot of terms, many terms? So when you go to higher level mathematics, the benefit or the advantage of this method will be more obvious. Keelan says, once you get in a groove of it, it becomes super easy. Thank you, Keelan. I appreciate your feedback, always very positive. But if some of you are not clear about what I said, please be straightforward. Yeah, I appreciate your feedback as well. I can try to explain in a different way. You understand, practice definitely is necessary. That's why you have to do a homework, right? You have over 100 problems to practice in person. But understanding is also important. I don't know. I think I said that before, right? At least twice. Yeah, practice one good question 10 times is better than practice 10 different questions. If you understand, you understand. If you don't understand, you practice 10 questions, you still don't understand. So this is a good question, by the way. To practice, how do you identify the structure of the equation? How do you apply transposition of terms to collect like terms? The reason we collect like terms is because we want the variable terms on the left side to get ready for isolating x in the last step. We cannot combine like terms if they are on different sides of the equation. So in order to combine them, we have to collect them first. Yeah, put them together first. But yeah, we can move the terms around, but every time we move a term from one side to the other side, we change the sign. Yeah, like this blue term on the right is negative, on the left is positive. We only have two signs, positive and negative, right? And then when the pink term is a positive on the left side, you move to the right, it becomes negative. Okay, so now I'm gonna give you a question and I want you to practice. I want you to practice number 6. Let me write it down. Number 6, negative 6x. And let me see this 6x. I think I messed up with. Copy. Paste. Give you a couple minutes. Yeah, work on this problem. My argument about selling my method is if you really grasp the method and you practice enough, you can get it done very fast, even in your head. All you need to do is to move the term over, right? But remember to change the sign. Very convenient. X equals 5. 15. 5 or 15? Did I see two numbers? Dakota? Why is it 15?
I meant 15.
Huh? Yeah. You mean 15?
Yes.
Really? You know, let's try to plug in. Negative 6, 15 equals negative 45 plus 3 times 15. Negative, this is 90 equals negative 45 plus 45, 0 on the right side, negative 90 on the left side. Yeah, so 15 is not a solution. Yeah. You said a 5 in the beginning.
Yeah.
What happened to the 5? Plug in 5. Yeah, you know you are able to double check your answer yourself. Give me 1 second, let me turn on the light. So I would recommend when you take the test, you have this habit to double check your answer. Yeah, let's try the 5. Let's try the 5. Left side, negative 30, right? Right side, negative 45 plus 15. 3 times 5 is 15. Negative 30 on the left side. Right side, negative 45 plus 15. You lost the $45 and then you gain $15 back. So your loss is less. Negative 30. That's true statement. So the answer is 5. Yeah. Okay. Yeah. Let's see how do we solve this problem. This is what I would do. Draw a line and then how many terms in it? How many terms in the equation? How many terms in the equation? 1 or 2 or 3 or 4? Yeah, in the equation. In the equation. 3 terms, right, Joe? In the equation, yeah, in the equation has 3 terms. In the equation, we have 3 terms. On the left side, 1 term. On the right side, we have 2 terms. This color. All right? Yeah. Terms. Yeah, I want to say that again. I'm going to say this over and over, and then you'll remember. 2 types we only concern. This type and constant. Yeah. So you see the pink belong to this category. The yellow belong to this type, right? The green belong to this type. Yeah. When we deal with this chapter, you only see these 2 types of terms. Okay? Yeah. And what we want is we wanted the terms with x on the left side, the terms without x on the right side. So this is what I would do. Keep negative 6x, bring the yellow over, but remember to change the sign. Bring the yellow over, remember, I believe you get a 15, you probably forgot to change the sign, right? And you must remember to change the sign. And then keep the green on the right side. Very, very important. Yeah, the only thing that changed here is the yellow term. Since the yellow term changed the side, you have to change the sign in front of it. Okay, negative 6x minus 3x, you lost 6 chips, and then you lost another 3 chips. You lost more than earlier, so you lost 9 total. On the right side is negative 45, right? Yeah. Once you have 1 term left on the left side, and when you need to get rid of the coefficient, yeah, when we need to get rid of the coefficient, negative 9, we don't do addition or subtraction, okay? We do division. We're going to divide each side by negative 9. And they cancel here. Cancel. So we have x isolated on the left side. On the right side, negative 45 over negative 9. Negative divided by negative is positive, positive 5. And also, if you are not sure, what do? You check. You get a 5 and you're plugging in. And remember, you have a calculator, so take advantage of that. Questions? Yeah, that's a common mistake. So I would say, I really hope you try my method, but it does take a practice, especially it's pretty easy to forget to change the sign. So you would have to remember to change the sign. Seemed easy, but not exactly easy. I had it right first, then wrong. Oh, okay. Yeah, that we need to practice more, right? Yeah, let's practice more. Let's do a decimal. How about that? Let's do this one. I'll do this one, okay? This one is a little bit different. This one, the structure not quite clear at the very beginning. Why? Because it has a grouping symbol. If we have a grouping symbol, what should we do? Last Monday, not this Monday, the first class, we have learned a property called distributive property, right? Yeah. So distributive property is to use to remove parentheses. Yeah, we must remove parentheses. Why? Because our goal when we solve a linear equation in one variable is to isolate the variable x on the left. Yeah, and on the left side is so complicated. It means we have like a grouping symbol. We want to break the group, break the wall, set everybody free. Then they can combine and simplify, right? All right, so let's apply the distributive property. Anyone tell me what is the thing that we need to distribute? Yeah, distributive property means we need to distribute something to each member in the parentheses, right? What's the thing? What's the coefficient of the parentheses that we are going to distribute?
Negative 0.7.
Awesome. Negative 0.7, okay? Not a positive. I would prefer you see is a negative 0.7. Yeah. And if that is challenging, you can always break things down, right? If one task is too much to you, you can break it down. And for example, you can move that part on this box, in this box, negative 0.7 times parentheses 4 minus x. And once you apply the distributive property, and you can put it back. Yeah, we can do that. You are right. The coefficient that we're about to distribute, yeah, is negative 0.7. Okay, negative 0.7. And in the group, we have two terms. The first term is 4. The second term is negative x. And we are going to distribute means we are going to multiply each single term by negative 0.7. Does that look familiar? We got it done. We get the same thing done in the first meeting, right? This is not minus 0.7. It is multiplied by negative 0.7. So let's see what we have. Yeah, we have 4 terms. Again, we have 4 terms in the parentheses. I'm sorry. We have 2 terms in the parentheses. The first term is 4. The second term is negative x. And our coefficient that we are going to distribute is negative 0.7. We are going to multiply the first term, number 4, by negative 0.7, and then multiply the second term, negative x, by negative 0.7. Let's see what we have after that. Positive times negative is negative. And you have a calculator, right? Yeah. As I said, I don't worry about the decimals because you can use a calculator to handle decimals very well. 4 times 0.7 gives us 2.8, negative 2.8. And x times negative negative x. Let me rewrite this, negative x. Negative x, yeah. Negative x times negative 0.7, negative times negative is a positive, and we have a positive 0.7x. All right, yeah, and then we put it back. So the first term after we distribute becomes negative 2.8, and the second term becomes positive 0.7x. Yeah, and now we can put it back here. Yeah, don't forget we have this term. That term we doesn't change it at all. Okay, in this equation, so far we only changed this part, the yellow part, and everything else remains the same. Bring 0.7x down, equal sign down, 4.9 down, and the yellow part, we only deal with the yellow part so far, and that is negative 2.8 plus 0.7x, right? 0.7x. Okay. Question. How many terms in the equation now at this moment? Four terms. Yeah, awesome. Very good. 4 terms. So this term and this term, they are like terms, right? And the two constants, they are like terms as well. So to collect the like terms in this case, all we need to do is to move the blue term over to the right side. On the right side, we have 4.9. We move the blue term over, negative becomes positive, positive 2.8. Right? Yeah, to collect the like terms in this question, in this step, all we need to do is to bring the blue term over. But please don't forget, change the sign. Negative will become positive. Negative 2.8 on the left side become positive 2.8 on the right side. Okay? And then combine like terms. Question, do we have a 0 on the left side? Question, do we have a 0 on the left side? And what's the left side supposed to be after we simplify it? Yeah, you are right. It's not. Thank you, Jill. Yeah, what's the left side supposed to be after we simplify it? Is it 0.7x plus 0.7x? We combine they are like terms. Yeah, we combine like terms by combining, yeah, exactly, 1.4x. Awesome. 1.4x. On the right side, 4.9 plus 2.8. You have a calculator, right? 7.7. Yeah. Once we have one term only on the left side, we are ready for the last step. To isolate x on the left side, divide each side by 1.4 by the coefficient. Divided by 1.4, divided by 1.4. So this cancel. We have x isolated on the left side. On the right side, we have 7.7 over 1.4. Yeah, you know what? I can draw a box and then process 7.7 over 1.4 in the box. In the box, okay? Yeah, if you have a calculator, of course, you can get a answer very quickly. Yeah, but suppose you do not have a calculator, what would you do? What you can do is you multiply both top and bottom by 10, and you change both top and bottom as integer. You have 77 over 14, and then you divide the top and the bottom by 10. And you don't have to do this, by the way. If you have a calculator, you really don't have to. And you have 11 over 2. Half of $11. Yeah, half of $10 is $5. Half of $1 is 50 cents. So 5.5. If you use a calculator to divide 7.7 by 1.4, you should have 5.5 as well. Awesome. Thank you, Sean. Dakota. Yeah, exactly. Awesome, guys. So when the equation involves decimals, yeah, I would recommend you use calculator. All right, I would recommend you use calculator. But you still have to know how to combine like terms. By the way, you still can use the casino method. You won 70 cents, and then you won another 70 cents. So you have $1.40 profit, right? Yeah. Keep the variable. Keep the variable. When we combine like terms, we combine the coefficients and keep the variable here. Do not change x to x squared or whatever. Okay, I'm gonna challenging you and make you to do a complicated question with decimals. Yeah, let's try this one. Take your time, okay? Take your time. You should start to work on the My Lab Math homework for chapter 2. This is a 12-week class. You would feel so fast the time passed, and then suddenly you have to deal with the first exam very quickly. All right, let me get you started. Draw the line in the middle. Yeah, I would simplify each side first. Okay, simplify. When the equation, the structure not very clear, like the terms are not separate, but the equation has groups, you must remove the parentheses and simplify each side of the equation. So let me get you started. This is the left side, this is the right side. Yeah, since the left side looks complicated, right side looks complicated, and we should simplify each side first. Okay, what you can do is you can draw a box and simplify the left side here. Draw another box, simplify the right side here. Then you don't mess up, right? When we have a lot of things, what do? We buy organizers, right? We buy boxes and we put them in an organized way. So try box method to organize your thing. If we feel confident on this chapter, can we start chapter 2? This is chapter 2, Kaylin. We are doing chapter 2. Chapter 3 is about the straight lines. It's a linear equation, 2 variables. This is 1 variable. I'm working ahead with it all. Then I have to make sure every single one of you feel confident, not just you. Yeah, I know some of them think this is very simple. Yeah, why are you still doing this? So simple. It is in the syllabus. Is like a core content that I have to cover. It is a core content. It means the teacher have to cover it in detail.
I think she means, can she work ahead in the homework?
Yeah, of course. Oh, okay. Sorry about that. Yes, totally. If that's what you mean, Caitlin, yeah. You can work on your homework anytime. As I said, if it's about to expire, I would remember to reopen it, like extend it, to make sure you always have that available to you. Yeah, you can start a homework anytime as long as it's open, and I'll make sure it's always open. Thank you, Killen. All right, work on this problem. Simplify each side. Yeah, work on the two boxes first. Work on the two boxes first. I'll give you 2 minutes, okay? In 2 minutes, I'm going to ask you to compare with my answer. Mathematics builds on the solve. So when we solve equation in chapter 2, we use what we learned from chapter 1, distributive property, terms, like terms, combined like terms. All right, guys. What do you have in the first box? Do you have negative 0.7x minus 1.5? In the second box, do you have negative 0.8x minus 1.6? If not, try to see what happened in your solution. If you don't see it, let me know. Very good, very good. Perfect. Yeah. So the left side of the equation now is negative 0.7x minus 1.5. Yeah, in the middle we have the equal sign. On the right side we have negative 0.8x minus 1.6. Okay, awesome. Awesome. Very good. Very good. Don't rush, okay? I'm pretty flexible, especially the remote classes, very flexible. For the exams, you go to testing center. If you need 3 hours, I'll give you 3 hours, as long as the testing center is open. So never rush your exams. When it gets closer to exam 1, I'm going to ask you, how many minutes do you want to set? Do you want me to set for exam 1? Normally 100 minutes. If you think 100 minutes is not long enough, you can I can give you more time, right? Yeah. All right, let's go back to this question. We're not done yet. Yeah, we're solving the equation. We're solving the equation. Our goal again is to isolate x on the left. Isolate x on the left. All right. Okay. So after we simplify each set of the equation, we are going to collect like terms now. Yeah, step 1, step 2. Collect like terms. Yeah, how many terms right now in the equation? Left hand side. Do you see 2 terms? Right hand side. Do you see 2 terms? And to collect like terms, I want this yellow, green. Yeah, so I want to collect the yellow and the pink together on the left. I want to collect the blue and the green together on the right. Please don't forget to change the sign. Okay, so we have a negative 0.7x, the yellow stay on the left side. Pink is moved over. Pink is moved over. So negative become positive. And blue moved over, negative become positive. And green. So this is green. Yeah, if I color them, I think it would help you to see what happened. Understand, see it is one thing, and you do have to practice. Sometimes the habit play a very important part. Like you don't have the habit to use my method, and you might mess it up. Now, how do you cultivate the habit? You have to really practice enough. Okay, so what happened to the 4 terms is yellow terms stay on the left, right? Does not change at all. Negative 0.7x, negative 0.7x. Green term keep on the right, doesn't change at all. Negative 1.6, negative 1.6. What I have changed are pink and blue. The pink term is moved to the left side, from right side to the left side. So, do you see the 2 pinks? They have opposite sign, right? When you move the pink from the right side to the left side, negative become positive. When you move the blue term from left side to the right side, oh, sorry, I accidentally put a X here. So that is blue. Let me double check. Yeah. So yellow keep on the left side, green keep on the right side, pink is moved to the left, so negative become positive. Blue go from left to the right, so negative become positive. Okay. I want you at least to see what's going on here. All right, at least see it. So that's collect like terms. We use the method that I introduced. And after we collect like terms, of course, we combine like terms. Let's combine them. You lost 70 cents, and then you gain 80 cents. You end up with winning, right? Yeah, 10 cents. So 0.1x. On the right side, you win $1.50, and you lose $1.60. You end up with losing 0.1, right? 10 cents.
The 0.3x you forgot to bring down is the like term also.
Oh, let me double check. Oh no, that's a very good question, but I did not forget. I did not forget. Look at my first box. I have a 0.3x. So my box, yeah, that's a very good question. How do you organize your thing? This is my left side. This is my right side. I have the whole left side put in a box. I have the 0.3x here already. Do you see that?
Oh, okay, I see it.
Yeah, yeah. But that's a very good thing to point it out. 0.3x minus 0.5 times parentheses. Yeah, I have this parentheses removed and then combine like terms simplified. Left side and the right side is here. Yeah, that's a very good question to point it out though. All right, last step. And we divide each side by coefficient 0.1, 0.1. And the 0.1 cancel 0.1 equals 1, right? Yeah. Coefficient is 1, then we only have x on the left, then x is isolated. On the right, we have what? Your calculator can help you, right? Negative 1. Negative 1. Yeah, we can add a step 5 to check your answer. Yeah, to bring in x here is negative 1, right? So that's a negative 0.3, and negative 1 times 2 is a negative 2. Negative 2 plus 3 is 1. So negative 0.3 minus 0.5, negative 0.8. Left side is negative 0.8. On the right side, negative 1 plus 2 in the parentheses. Yeah, PEMDAS, remember, please excuse my dear Sally. Negative 1 plus 2 is 1. 1 times the negative 0.8 is a negative 0.8. So left side and the right side are equal. It does satisfy. Okay, do you have the same question? Yeah, actually this one is for you to practice, but actually I provided the solution, most of the part. Okay, now let's practice more. We have 7 minutes, so we are going to practice some simple question, all right? Next Tuesday when we meet, we are going to practice linear equation in one variable involving fractions. Today, integers, yeah, this equation only can turn integers. And then we practice 2 questions concerning decimals. And next time when we meet, we are going to solve equations involving fractions. Yeah, it's probably a little bit more challenging, and we run out of time today. Yeah, let's practice. Solve this question. Tell me what is x. Number 1. Yeah, identify how many terms. This is so easy, guys. 3 terms. As I see, 3 terms. All I need to do is to move 15 over. Don't forget to change the sign. Move 15 over and become negative 15, right? What is that? 4. Very good. And second question, you move the negative 9 over, or you plus 9 to each side, right? What do you have? Negative 7. And number 3, decimal. All you need to do is to move 9.8 over, but minus, right? Yeah, minus. So negative 9.2. Let me see if you have the same thing. Is it positive or negative? The sign is important. Sign error is one of the most common mistakes. Sign error. You mess up a sign and the answer is incorrect. You don't get a point. And I'm not able to override for that, for the sign error, because it's an error, it's a mistake. Try number 4. You want to simplify the left side first. decimal. Simplify the left-hand side. 11.6 minus 7.8. What do you have? Our calculator policy is only scientific calculator. Yeah. And you want to have a scientific calculator with you. To be familiar with the calculator you have. I do not recommend you borrow a calculator right before you go to the testing center to take the test, because every calculator is different. Sometimes you are not familiar with the setting, you will not fully take advantage of the calculator. So I have a 0.4. 11.6 minus 7.8 is 3.8, and 4.1 minus 3.8 is 0.4. Let's see if you have the same number. Huh? Did I mess that up? Let me do it again. 11.6 minus 7.8, 3.8. 3.8. Oh, yeah, you're right. 11 minus 8 is 3. My bad. 0.3. Okay. And let's try number 7, this one. 42 minus 7x equals 2x. Yeah, I want to talk about this question a little bit. This question, I would isolate x on the right side. Okay, I would isolate x on the right side. Yeah, this is the case. Isolate x on the right side is more convenient. Yeah, let me explain why it's more convenient. Because you don't want to handle negative sign, you want to handle positive sign. So for this question, I'm going to keep the constant terms on the left side, variable terms on the right side. Yeah, what happened is this term, negative 7x. What I do is I move the blue term from left to the right, and negative 7x becomes positive 7x. And what is 2x plus 7x?
9.
9x. Dakota have a decimal 4.6. Yeah, 9x. And then, yeah, we isolate x on the right side, and we avoid have a negative sign, right? If you don't feel comfortable at this point, right after this step, you can switch the side. If 42 equals 9x, then 9x equals 42. It really depends on how do you feel comfortable with this type of question. And then we divide each side by 9. We have x equals 42 over 9. And you can use a calculator to get 42 divided by 9. They both divisible by 3. So 14 over 3. Am I right? 14 over 3, right? My brain is not working well today. So divide 42 by 3, 1, 4. Yeah. It's 14 over 3. I don't think we should write it as decimal. Okay? I do not think we should Dakota, we do not write that we don't round, you know. Yeah, same with Amanda. When we could write the answer exact as a fraction, we don't round it as decimal. Because the 4.7 or 4.6, after you round it, is not the same number. When you plug in, you will not have a equation. You will not have a true statement. For real, yeah. You have to keep exact number. The exact number is 14/3. Yeah, am I clear about that? I know you rounded it, you have like a 4.6 or 4.7, but those numbers do not satisfy. Do not satisfy. Okay? And the question will not ask you to round it. Will never ask you to round it when you solve an equation. Maybe I won't work ahead. Oh, okay. Yeah, you can look at those questions. There are around, I think, 120 questions, and you can take a visualize. If you are able to visualize you can you know the steps, then you feel comfortable, you can work on the problem. If you, after you read the question, you have no idea and it's challenging, then you can leave that question for later. All right, guys. So we're gonna stop here today. Today is Wednesday. I'm going to see you on Monday, and we're gonna continue working on solving linear equations in one variable. Yeah. Thank you guys for coming. Have a good night. Thank you, Kaylin. Bye-bye.
Night.
Good night.